I have a problem. I'm going to host a networking event for which I am going to purchase the snacks and the beverages, and I'd like to figure out the total cost of the party. A logical process for solving this problem is to first get the snack cost, then get the beverage cost, and finally calculate the total cost by adding the snack cost and the beverage cost together. This outline of a logical process for solving the problem is called an algorithm. Notice that an algorithm does not contain any specific values for the data. Instead, it refers to the data in generic terms. As a result, the algorithm describes a logical process that will work correctly regardless of the actual values of the data. So for instance, if the snack cost is $14 and the beverage cost is $8, the algorithm would correctly calculate the total cost of $22. On the other hand, if the snack cost is $24 and the beverage cost is $10, the algorithm still works correctly, finding a total cost of $34.
This example illustrates the first two steps of the overall programming process. The first step is understanding the problem to be solved, followed by designing an algorithm outlining the overall logical roadmap for solving it. The next step is coding, in which the algorithm is translated into a program written in a specific programming language, like R or Python. The final step is testing the program by running it and examining the results to make sure they are correct. It is very rare, even for relatively simple problems, for a program to run correctly through each step the first time. Rather, the programming process is cyclic, with errors being found at one stage of the process that often require returning to an earlier stage to find and fix the root cause of the error. For example, while writing the algorithm, you may realize that there was some aspect of the problem itself that was not clear, and so you will need to return to the problem understanding step for clarification before you can continue to develop the algorithm. Similarly, when writing the code, you may realize that there is a problem with the algorithm and need to return to the algorithm design or even the problem understanding step to correct it. And finally, you may find errors in the results during testing that could be caused by a coding error, an algorithm design error, or an error in understanding the problem itself. To fix the error, the appropriate steps will need to be revisited, corrections made at each step to address the issue, and the program retested. This cycle of creation, evaluation, update, and testing defines the programming process that starts with a problem and ends with a correct solution.
Now let's review our key points. First, remember that programming is a process. It is not simply going directly to writing code. The first step of the process is to understand the problem that needs to be solved. Clarify any ambiguous, missing, or contradictory information before moving on. Misunderstanding the problem will not lead to a correct programming solution. The next step is designing the algorithm, which is the logical outline for solving the problem. The algorithm should be general and its logic should be valid regardless of the specific data values. The algorithm is then used as the basis for writing the program. The correctness of the program is then tested by checking that the results it generates solve the initial problem. The program should be tested with a variety of data values to make sure that the overall logic is correct. Finally, remember that the programming process is cyclic. An error found in one step often requires revisiting previous steps to find and correct its root cause.